Now let's look at a question, averages, two-tail, and let's put all the interpretations and proper wording into this problem. Alright, the problem goes as follows. The manager of operations in a warehouse routinely checks the demand for the major items shipped from the warehouse. Inventory control of a particular product is optimized on the working assumption that average daily demand is 1,200 units. Over the last 100 days, the average daily demand is 1,174 units, with a standard deviation of 76.3. Is the actual average daily demand equal to 1,200? Use an alpha of 5%. Alright, so first thing, the sample data. That comes in this sentence. Alright, over the last 100 days, the average daily demand is etc. So the 100 days is the sample size. We have 100 numbers. We add them up, divide by 100, and we get an average of 1174. And we get those same 100 numbers, take the standard deviation, and find 76.3. Alright, so let's write that down. So sample information, we have an N of 100, that's 100 days. We have a sample average of 1174 and a standard deviation of 76.3. Okay, and we're asked to do this with an alpha of 5%, which is the standard alpha, which we've used so far. So, hypotheses first. Null hypothesis would be that the true average daily demand is 1,200. The working assumption, so mu is the true value, the 1,200 is the working assumption. So the true, and over here we have the assumption. Okay, so for words we can have here that the working assumption is correct. The alternate, have mu not equal to 1,200, right? It's the complement of the null, and the working assumption is not correct. Next step is to do our distribution. So we can start off our calculations. And have the middle of the distribution and critical limits. Alright, when we do this we go back and look at the null hypothesis, and we have the null with mu equal to 1,200, so that's where we center the distribution. Remember, we were asked to use an alpha of 5%, so we have 2.5% in the two tails, each of the two tails. And we have the mean 1,200. To be able to calculate these limits, we need the standard deviation of the sampling distribution, S of x bar. Remember, this is the sampling distribution, and we need to do that calculation. So let's go off here on the side and do that. So S of x bar is S divided by the square root of n. S 76.3 divided by the square root of the sample size of 100. The square root of 100 is 10, so divide 76.3 by 10 and we have 7.63. Okay, so the estimated standard deviation of this sampling distribution of sample averages is 7.63. So, other than the z-value, which we had from prior examples, we can calculate the critical limits. Being in general mu plus or minus the z-value with the subscript alpha divided by 2, so half alpha in each tail, times s of x bar. Okay, and note that the z-value that we have here is a z-value with 2.5% in the tail, which is the 1.96. And as a quick review, let's look at the tables. The last row is for the z distribution, and we want 2.5% in the tail, so the number we want is 1.96. Alright, so now we're ready to calculate these critical limits. Mu, middle of the distribution, 1200, plus and minus the z-value 1.96, times the standard deviation of the sampling distribution, 7.63. Alright, so that'll be 1200 plus and minus 14.95. Alright, so 1200 minus 14.95, round off to 4 significant places, so 1185, and 1200 plus 14.95 is 4 significant places is 1215. So these two numbers, the 1185 and the 1215, are our limits to the acceptance region. So if the null hypothesis is correct, if mu is equal to 1200, if the working assumption is correct, then normal sampling error will put sample averages somewhere between 1185 and 1215. Okay, so we expect to see a value in here if the null is correct. On the converse, we do not expect to see a sample average beyond 1215 or below 1185 if the null is correct. Right, so those ideas form the basis of our decision rule. Now we'll write down a decision rule. Alright, first part for the acceptance region. If x bar is within the acceptance region or between the 1185 and the 1215, we'll say from now on out, do not reject the null. And for the interpretation, it is possible the null is correct, or in this case, it is possible. Let's look back at the words that we used to describe the null. It's possible that the working assumption is correct. Second part of the decision rule corresponds to the alternate if x bar is in the tails. In other words, if x bar is not between 1185 and 1215, puts us out in the tails where the alpha is, then the sample value is too far away from the hypothesized value of 1200, so we'll reject the null and in its place accept the alternate. And for the interpretation, it is likely the alternate is correct, or in this case, scroll up again, is likely the working assumption is not correct for the alternate. It is not correct. Once we have gone this far, the rest of the problem is easy. What we now need to do is to go find our particular sample average, the 1174. 1174 is some number below 1185. Let's say it's down here somewhere. Puts us in the rejection region. So we follow part 2 of the decision rule. So decision, since our particular sample average is 1174, is not between those two limits of the acceptance region, 1184 and the 1185 and the 1215. Alright, following part 2 of the decision rule, I'll just write it as the decision rule goes. We'll reject the null and accept the alternate. And follow along with the decision and the interpretation. Is likely the working assumption is not correct. In other words, the sample value is too far away from the hypothesized value of 1200 to be reasonable. So it's likely it's not correct. And that's the end of our hypothesis test here.